Okay, so in this video, we are going to calculate the Laplace transform for piecewise function h of t, which is defined as 5 for t values between 0 and 2, and it's defined as e to the 8t for all values of t greater than 2. So starting with the definition of the Laplace transform, we're going to do this piecewise function the same way as the other examples. So the Laplace transform of h of t is defined as the integral from 0 to infinity of e to the minus st times our function h of t dt. And since our function h of t is defined piecewise, let's start, if we started at 0, then we would want to integrate up to 2, because over the integral from 0 to 2, h of t is defined as 5. And then, as t goes from 2 up to infinity, suddenly h of t is now changed. So we're going to integrate e to the minus st times e to the 8t. And we're going to integrate this with respect to t. Okay, so we've got two different pieces, and this gave us two different sums of integrals. So integrating the first one with substitution, here we would get minus 5 over s times e to the minus st, and we are evaluating that from 0 up to 2. And then for the second piece, that one is now going to be our improper integral. So for this one, we're going to take the limit as n goes to infinity, and let's combine the powers of the exponents inside the integral. So we're going to integrate from 2 up to n, and I can write this as e to the 8 minus s times t, and we're integrating with respect to t. Okay, so taking the first stuff, I can plug in 2 for t. And so remember, our variable is t, and we treat s like a constant. So first plugging in 2, I would get minus 5 over s times e to the minus 2s. And then we're going to subtract from that what I get when I plug in 0. So that's going to be minus 5 over s times e to the 0. So that's the first integral. And then for the second integral, we haven't integrated that yet. So we still are taking the limit as n goes to infinity. And using substitution on this one, we would get 1 over 8 minus s times e to the 8 minus s t. And we're evaluating that from a lower limit, which is now starting at 2, all the way up to this upper limit n, which is heading off to infinity. So, therefore, we can simplify all of this, and our Laplace transform, which we can write as capital H of s. So if I take the first term here, I can combine the two negatives, and that's going to give me a positive 5 over s, and e to the 0 is 1. And then I subtract the 5 over s, e to the minus 2s. And now for this limit, we've seen this sort of limit already, and that is as long as the power of the exponent is negative, so in other words, as long as s is bigger than 8, then we know that that is going to head to 0. So the limit, the upper limit is going to go to 0, and then for the lower limit, we're going to have a negative 1 over 8 minus s, all raised to the power of e to the 8 minus s, and now I plug in 2 for t. So that would be our Laplace transform. Maybe that looks a little odd with that 0 in there, so we could clean this up a little bit if you like, and write this instead as h of s is equal to 5 over s minus 5 over s times e to the minus 2s and then we can just ignore the 0 and then write the minus 1 over 8 minus s. Instead, I could write that as plus 1 over s minus 8, all times e to the 8 minus s times 2. So here is an equivalent way of writing this out, and we just want to again make mention here that the domain of this Laplace transform is defined as long as we set s strictly greater than 8. So that's how we could calculate the Laplace transform of a piecewise function. So in the next slide, we're going to just organize some of these results into a table of common Laplace transforms, and we can use this table when we're working through some of the problems in Chapter 6. So we're not going to always have to do all of these Laplace transforms by hand. Now that we've done several of them, we can summarize these results in a table, and then we can refer to this table in future problems.